This is question 5 of the GLM chapter of the Regression Models book. It asks, true or false, some GLM distributions impose restrictions on the relationship between the mean and the variance. You can read the chapter and of course know that this statement is true, and I'd like to focus on the discuss part of this. So let's just start by giving an example. Throughout this chapter we've been using the Poisson model with a log link as our canonical example. So we will usually model the expected value of the yi, our outcome. The log of the expected value of yi is beta naught plus beta 1 xi. So let's call that log of mu I. We are also assuming that yi is Poisson with mean mu I. The implication of this exponential family assumption is that the expected value of yi is mu I, as by definition. However, for the Poisson distribution, the variance of yi is equal to the expected value of yi, which is equal to mu I. And this is simply because the mean and the variance of the Poisson distribution is always the same. Now this is a checkable assumption in some cases. For example, if we have a lot of repeat measurements of yi at the same value of mu I, we have several counts, we can calculate its mean, say y bar, okay, and we can calculate its variance, right, the variance of the yi's. Let's just take, for example, that there was no xi. Let's just assume we had a bunch of independent realizations of Poisson random variables. Then we could calculate y bar, and that would give us an estimate of mu. And then we could calculate the variance of our y's, which would give us an estimate, would also give us an estimate of mu under the assumption that the y's are Poisson. So we can check if those things are close, then the Poisson assumption is validated. If they're not close, then the Poisson assumption is not validated. And so this mean variance relationship has potentially the problem that it's very different from what the data actually says. The solution to this often is to relax the assumption and no longer assume that y is Poisson, but instead assume a slight generalization of the Poisson distribution, such as the negative binomial distribution, or to focus on a more asymptotic, less modeling-based approach, such as so-called quasi-Poisson models. But at any rate, to answer the question, for the Poisson distribution, for the Bernoulli distribution, and many other instances of generalized linear models, there is an implied relationship between the mean and the variance, and often that relationship is checkable, and so whenever we're actually doing generalized linear model analyses, we should either automatically account for the potential that that assumption is false with quasi-models, quasi-likelihood models, or actually verify that it's true.